In this lesson we're going to be continuing with the work we've been doing, finding fractions of an amount, but this time we're going to move on from using our unit fractions and begin to look at non-unit fractions. So let's think back to our last session and the strategy we used to find our unit fractions of amounts. So the first stage was we represented the total amount as a bar, so that bar represents everything. Then we decided to label the bar with the total amount so we knew what that everything was. So whether it was a big number or a small number made no difference, we just needed to know that bar that represents everything, how much it was. We then divided that bar into the equal parts we were being asked for. So in this case I've taken my whole bar, my 45, and divided it into 9 equal parts. This means that each of those parts represents 1/9. Now the next stage was where I started working out that fractional amount. So what I've done is I've taken my 45 somethings and I've shared them equally amongst those 9 groups. So I've worked out that 1/9 of 45 equals, in this case, 5. And here you can see that I've identified the fraction that I'm looking for by highlighting it yellow. So I've identified that 1/9 of 45 is 5. So that was how we found out a unit fraction of an amount. And now we're going to apply that strategy to finding non-unit fractions of amounts. So opening up our textbook, we can see that our problem again is relating to our kitchen scene, where we can see a recipe for the toppings for 1 chocolate cake. For question 1a, we're asked there are 35 raspberries in a bowl. How many raspberries are used on 1 cake? And for question 1b, there are 35 strawberry laces in a bag. How many strawberry laces are used on 1 cake? So when looking at these two questions, the first thing to bear in mind is we've got our recipe, which shows us how much of each item we need for the cake topping. And the first thing to think about is, how are these fractional amounts different from the last session we did? Then looking at them really carefully, think about what does the denominator represent for each of those items. So the denominator for the chocolate chips, the raspberries, or the strawberry laces. And then what does the numerator represent? So now what you can do is you're going to go and independently attempt that first question. So question 1a, there are 35 raspberries in a bowl. How many raspberries are used on 1 cake? And question 1b, there are 35 strawberry laces in a bag. How many strawberry laces are used on 1 cake? So pause the video now and give that a go. Then come and join me when you're ready to look at the different strategies we can use to answer these and see whether your strategy agrees with the one that I'm currently using. So let's have a look at question 1a. There are 35 raspberries in a bowl. How many raspberries are used on 1 cake? And I've started by counting out 35 counters to represent my raspberries in this case. So you can see straight on the screen I've got my 35 raspberries. And those 35 raspberries are the whole amount, so they equal that whole bar that you can now see on your screen. That bar is going to represent those 35 raspberries. Now I know I've got 35 raspberries, I can see them on my screen. I know that they represent all the raspberries in my bowl, hence the fact that I've got 1 bar. But how much raspberries do I actually need? Now looking at the recipe, we can see that I need 3/5 of the bowl of raspberries, so I need 3/5 of 35 raspberries. So the first thing I'm going to do, I'm going to take that whole bowl and I'm going to split it into the amount the denominator tells me, the denominator being 5. So my bar now gets split into 5 equal parts, as you can see in front of you. But how much does each one of those parts equal? Well, each part is going to be 1/5, one of the 5 parts that make up the whole. So now we can see that I've represented that bar into fifths. Now what I've done is I've taken my bar that's split into fifths, and then I've taken my 35 raspberries, which I've represented as my red circles or counters. And all I've done here is I've divided or shared them into 5 equal groups, because we need to remember a fraction means an amount, a whole, that is split into equal parts. So in this case my bar is split into 5 equal parts, so I've taken my 35 raspberries and I've shared them into 5 equal parts, 5 equal groups. So we can see here that 1/5 of my 35 is represented by 7 raspberries. And here you can see it highlighted as with the last session. 1/5, which is the amount I'm looking at the moment, is 7. However, I'm not working with 1/5 because if we look back at the recipe, we can see that I've got 3/5 of a bowl of raspberries is how much I actually need. So nice and simply what I've done is I've highlighted 3/5. So 1/5, 1/5 and 1/5, and we can see that in each fifth I have 7. So I've got 1/5 plus 1/5 plus 1/5 equals 3/5. 7 plus 7 plus 7 gives me an answer of 21. So 3/5 of a bowl of raspberry, if there's 35 raspberries in that bowl, then 3/5 must equal 21 raspberries. And in this case I'm going to use exactly the same strategy for question 1b. There's 35 strawberry laces in a bag. How many strawberry laces are used on one cake? Once again, I've represented my 35 strawberry laces as 35 counters, 35 red circles. These 35 strawberry laces, these 35 counters, are the whole of my bowl, so it's the whole of my bar. So that 35 is the entire bar. However, I don't want all 35, I don't want the whole bowl in this case to be able to be on that cake. I'm being told by the recipe that I'm looking at 3/7. So I'm looking at my denominator, and that's telling me how many parts I need to chop those strawberry laces into. So that whole bowl of strawberry laces are going to be placed into 7 equal parts. And each one of those 7 equal parts is going to represent 1/7 of my strawberry laces. Now once again I've taken my 35 strawberry laces, represented by my red circles, and shared them out equally amongst those 7 equal parts. So you can see that each of those sections on my bar has 5 counters in to represent 5 strawberry laces. So 1/7 of that bowl, or 1/7 of those strawberry laces, is 5. Because I'm not asking for 1/7, I'm asking for 3/7. So what I've done now is I've highlighted 3 of those 7 parts. 1/7, 2/7, 3/7. That gives me 5 strawberry laces, 10 strawberry laces, 15 strawberry laces. So 3/7 of 35 strawberry laces is 15 strawberry laces. So before we move on to complete the rest of those textbook activities and moving on to the independent work in our workbook, let's just have a little recap on what we've done. Let's remember what we've been looking at today. And you're going to notice most of these steps are exactly what we did yesterday. The only difference is we're moving from unit fractions, where the numerator is always 1, to non-unit fractions, where the numerator will be larger than 1. And step 1, we represent that total amount, the whole thing, as one whole bar. Label your bar within the whole amount. This makes it easier for you to see when you're working back whether there's been any mistakes that have happened. So in this case, that whole bar is worth 45. Then look at the fraction that you're working with. What's the denominator? Because that bar that's in front of you is now going to be chopped into that many equal parts. So in this case, I've got my 45 and I've chopped it into 9 parts, which means I must be working in 9ths. So once I've got my bar, my whole bar, and I've chopped it up into the denominator that I need, I'm then going to share out the amount that I started with, that total amount, equally into those parts. So here I've got 45, and I've shared 45 equally amongst those 9 parts. I could have used counters to help me, I could have done pictures, I could have done a mental strategy, whichever way I want. But what is very important at the moment is that I'm recording this on the bar model, so we can see what steps I've actually gone. And here we can see that 45 shared by 9 gives me 5. So that means 1/5 of 45 is 5. Now our next stage is we're identifying the amount of parts of a fraction that I need. So if I only need 1/9, perfect, I've got 5. But in this case, I'm going to be looking at a non-unit fraction. And here my non-unit fraction is 3/9. So you can see 3 of those 9 parts I've highlighted, and you can see that each part has 5 in. So 1/9, 2/9, 3/9, 5, 10, 15. So in this case, 3/9 of 45 equals 15. So what would 5/9 be? Pause the video and see whether you can use that strategy. Looking at what's in front of you now, can you work out what 5/9 of 45 would be? So pause the video and join me when you think you've got your answer. Perfect. The answer would be 25. 1 ninth, 2 ninths, 3 ninths, 4 ninths, 5 ninths, 5, 10, 15, 20, 25. So 5 ninths of 45 would be 25. So think about the steps that we've gone through on this method. Complete the different questions that are remaining in your textbook before you move on to that independent work, and I look forward to seeing how you get on with this new strategy. Good luck.